Hello, algebra students. Please add to this little slip of paper that it is 4-1 and also put your name, date, period on this slip of paper. So this is a little graphic organizer that summarizes what we're going to be learning in 4-1. The words we're going to fill in, but for every single example in these boxes, we are looking at a system of equations, and we're going to be solving systems of equations, which we're going to learn about. And this concept summary is something that you're going to want to look back at. So, solutions to systems of equations. For the purposes of this lesson and this topic 4, we're only going to be looking at lines, and we're only going to be looking at 2 lines for the most part. Unless you're advanced and we give you enrichment, you just need to worry about lines for this chapter, and most likely only 2 lines at a time. Of course, we can graph more than 2 lines at once, and you'd have more than one solution. But that's enrichment, so that's going above and beyond what we're trying to learn. So sometimes you can have just one solution. And the reason we have one solution is because we have 2 different lines. We have y equals negative x plus 9, and we have y equals 3/5 x plus 3. And so you can see if we are to graph those 2 lines, the red line goes here, and the blue line is here. They cross each other at exactly one point. The point at which they cross is the solution. And you can see there's only one place that they cross. Okay, and on this next one, we have 2 equations. We have the y equals negative x plus 9. We also have 2y minus 2 or equals negative 2x plus 18. Essentially, these 2 equations are equal to each other, because if you divide the blue equation, everything by 2, you get the red equation. And when we graph those, the 2 lines are on top of each other, intersecting at infinitely many solutions. So infinitely many solutions. And you can see that in the line down here. So infinitely many. And our last problem, or our last box in our graphic organizer, shows what happens when we have parallel lines. When you have parallel lines, they never cross, so you have no solution. And the reason why is because they are parallel. So this is kind of the vocabulary that you're going to use today. We're going to be graphing lines. We're going to see if they cross, if they're on top of each other, like the same line, or if they're parallel. And it's called systems of equations. All right, so save this concept summary. Go ahead and put 4.1 or 4-1 on the top, and you're going to keep all of your chapter 4 notes and resources together. until we take our topic 4 test. And then when we take our topic 4 test, I will collect all of that. I'm going to go over the problems that we will be doing in class for this additional practice. And then the ones that I don't do are extra practice for you to do on your own. Or if we have time, you can do them in class. So number 1 says use a graph to solve each system of equations. Then we list the solution. So there's 2 parts to this. We have to graph it, and then we have to list the solution. So for number 1, if you remember how to graph, the -1 is the y-intercept. So I'm going to put a point here. Then we have 2 as our slope. So I'm going to rise 2 and I'm going to run 1. Go up 2, run 1. Okay, I'm going to erase that though just so it's not in my way. And then I'm going to plot these points, or I'm going to draw the line through these points. Then I'm going to graph the next line. So the y-intercept is -7, which is way down here. I don't know why they want us to graph these on graphs that are too small. And then the slope is -4. I don't want to go down 4 though, because I just don't have enough room. So I'm going to go up 4, but then to make it negative, I'll just go to the left. So 1, 2, 3, 4. To the left 1 is right here. And that's convenient because that's where the lines cross. Luckily, they cross on the graph. So the place where they cross, if you remember what we just did in our concept summary, that's the solution. So I need the coordinate point. The answer is the coordinate point where the 2 lines cross, right here. So that's -1, -3, where they cross. Right, and that's the answer to number 1, both parts. We graphed it, and we listed the solution. Number 2 is going to be a little bit trickier because they gave it to us in standard form. They didn't give it to us in slope-intercept form. So I'm going to show you how to make that into slope-intercept form. And I'm going to use the space over here, the blank space, to solve this equation to put it into slope-intercept. So I'll rewrite the equation, 18x minus 3y equals 21. I'm going to need to get y by itself. I need to isolate y. The first step in doing that is getting the x on the other side. Okay, so that makes these cancel, leaving us with bringing down -3y. The -18x and the 21 are different terms, so we cannot collect them. It's just -18x plus 21. The next step is to divide by -3, and everything gets divided by -3. The -3 cancels, leaving us with just y, which is what we want. Y equals 6x, because 18 divided by 3 is 6. The negatives cancel. 21 divided by -3 is -7. So that helps us when we're graphing it. Not great though, because again, it's off of our graph, but that's okay. We'll just come down 1, 2, 3. We'll put a dot here. That's our y-intercept at -7. And then our slope is 6. So rise 1, 2, 3, 4, 5, 6. Run 1 right here. So I'm going to erase my slope marks and I'm going to connect these dots. And then I'm going to graph the other line, which thankfully is in slope-intercept form already. But what do you notice about this equation? It's at -7 and the slope is 6, which puts us here, which means it's the same line. And since they're the same line, there are infinitely many solutions. And then I'd like you to try number 3 on your own. So try it. And then I'm going to do 2 of these problems for you, maybe just 1. We'll start with 5, and if it looks like we need another one, then I'll do another one. So the y-intercept is -3. Put a point at -3. Zoom in. And the slope of the first one is 4. So we're going to rise 4. We're going to run 1. Connect. And then the other equation has a y-intercept of -5. So I'm down here at -5. And a slope of 8. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to run 1. And then we have to guesstimate or estimate where those cross. Ooh, my line is horrible. I got to redo that. It doesn't want to. It's too straight. Okay, this is a little bit harder to see where they intersect. It looks like they're intersecting. Let me grab a different color. Looks like they are intersecting at half. So the point where they intersect looks like 0.5, because we go right 5, and we go down 1, so -1. And that is an estimate, because I don't know for sure if that's where they cross, but that's what it looks like to me. Now let's do another estimating one, and then you can go back and do number 4 on your own. So the y-intercept is +7. So this would be 5, this would be 6, this would be 7 up here. And then our slope is -3, so down 1, 2, 3, over 1. Puts us here. We could do another point here, just to get an extra straight line. And then I don't have to leave my point way up there. I just won't go through it, so that way it's not in the way. Since I went down 3 over 1 multiple times, I don't need that 4th point up there. Then I'm going to graph my other one, except it's not in slope-intercept form. So I'm going to rewrite it. X minus 2y equals -6. I want to solve for y. Solving for y is tricky. The first step is isolating the y's to -x from both sides. That cancels. We're left with -2y equals -x minus 6. Don't worry about this subtraction -6 minus x, because you're not actually subtracting them. You're just bringing it to the other side using subtraction. So we're going to divide everything by -2. So this cancels. Then we have y equals -x divided by -2 is 1/2 x, because there's an invisible 1 in front of the x, so it just makes it 1/2, and the negatives cancel. -6 divided by -2 is +3, so I need to write +3. And now I can graph it. My y-intercept is 3. My slope is 1/2, so that means I'm going to rise 1. I'm going to run 2. Puts me there, and I can go backwards and put points 2 just to make it a straighter line. And where are they crossing? They are not crossing at a beautiful place. They are crossing right here. And that looks like a little bit more than 1, so maybe 1.25. And then they're crossing, like, for the y value, that would be about 3.5. So I'm just kind of guessing where this coordinate point is. And that's our estimated solution for this system of equations. A system, remember, is 2 lines that are crossing. So go back and do number 4. You can pause the video. And then I want to do number 8 with you. Elena and Marcus jog after school each day. One day, Elena and Marcus jogged a total of 15 miles. Elena jogged 1 more mile than Marcus did. Use a graph to find the number of miles each person jogged. Well, this is kind of tricky. Together they have a total of 15 miles. So Elena plus Marcus have a total of 15. Elena jogged 1 more than Marcus, so Elena's miles equals Marcus's miles plus 1. Now, we can graph these, but it's kind of hard because we don't know what's x and what's y. So since this equation is already looking like y equals mx plus b, because the variables are separated, I'm going to change it to y equals x plus 1. So now the e for Elena, we're going to use y, and the m for Marcus, we're going to instead use x. And we'll do that in our other equation. So for this equation, the e is going to be y, and the m is going to be x, and that equals 15. Now we can graph those 2 equations. So we're going to graph y equals x plus 1. We're going to graph y plus x equals 15. I'm not going to solve it for y. I'm not going to put it into y equals mx plus b, and I'll tell you why. It's in standard form. This guy here is in standard form. Standard form, we can do the intercepts. So if I cover up the x with my finger, then y equals 15. So I can just put a dot right here at 15. And if I cover up the y, then x equals 15. So it's much easier just to do intercepts when it's in standard form if it's just y plus x, or if it's something I can divide easily, then we would just leave it in standard form to graph it. Okay, and that's our line for the black equation. For the blue equation, we have a y-intercept of 1, that's here, and we have a slope of 1, which we don't see, but we're going to rise 1, run 1. Rise 1, run 1. Our scale is counting by 2s, so that's why I'm only rising, it looks like a half. But if we rise 1, run 1, this is essentially what we get. And we find that they cross right here. That's our solution. This is our solution where they cross. So that point is at 7, 8, which means that Marcus, because Marcus ran less, right? Elena jogged 1 more. So Marcus ran 7 miles and Elena ran 8 miles.